There are a lot of projects relating to AI and machine learning that secondary students can do. So the next steps for them in AI and machine learning would involve building skills in the area of intelligence, natural language processing, data analysis and visualization, training and testing machine learning programs and algorithms, and of course some programming. So look at the top two images here. One's a factory, one's a farm. Do you see any people? I see lots of robots in the factory, and I see what looks like a custom made robot designed to do agricultural work, but no people. Well, so the ideas for secondary kids to get relate to intelligence, automation, the skills that they may need for their future. So, again, what's intelligence? What are the human strengths, the strengths of machine intelligence? What are appropriate jobs for robots in the future and for people? And how about for a robot machine partnership? So, what do they need? What skills do kids need, do adults need in the future to thrive in a machine learning environment? And maybe could artificial intelligence and machine learning actually be integrated into the human body and the human brain in some way? So the goal is to help kids deepen their understanding of this. So it's not something that is mysterious. We want to demystify it so they can think about it clearly. So natural language processing is a good place to start. The guy with the red circle around his head is Ray Kurzweil, who invented the first reading machine in 1976. And what would a reading machine do? What do machines that handle language today do? Well, they read printed and handwritten words. They can hear words, and they can combine those into phrases that have some kind of meaning. And maybe they can take action on that meaning. For example, a chatbot in your school. Say somebody may say or type, I need to speak to the principal. And the chatbot hears the word principal and knows that, oh, the action is to connect that call to the office. How deep is that understanding? Does that chatbot know what a principal is, know even what a school is or a person? Meaningful understanding is a much deeper level, and it's appropriate for students and teachers in class to probe these ideas to see how good is our machine intelligence now. Our digital devices can generate language, they can speak, they can translate languages. It's pretty cool. Kids can do this with a free program such as Snatchbot. Uh, Snatchbot even has chatbot templates where they can go to the site and very quickly, like in one class period, create a chatbot and test it. Uh, Chatbots normally are programmed for specific words, but the person speaking doesn't always choose those words. So there's a way to build what's called a text classifier, where the system can try to figure out what word do they really mean, even if they don't use that exact word. Uh, in the uClassify site, students can go to that site, and again, in one period, try nearly 100 different pre-made text classifiers. And with a little extra work, they can create their own text classifier that they can use in real projects. To build voice into a chatbot, there's a site called Cognimates, and another one created by a UK professor by the name of Dale Lane, where they both created Scratch extensions to allow voice activation of a chatbot within Scratch. Dale Lane's even connects to the IBM Watson supercomputer. So Cognimates and Dale Lane have created Scratch extensions. These are shown as the green tiles that are added to Scratch. So this is great for students up to 8th grade, even beyond. So on the left, we see tiles, programming tiles related to speech. So a tile that can turn on listening, turn it off, that can listen for a specific word, It can speak words. It can even translate from one language to another. On the other side, on the right-hand side, we have uh, vision training tiles, such as one that can search for an image using a particular link, or choose a pre-trained video model, uh, or ask how sure is the system that this image is of a particular thing. So very, very cool things. Uh, Cognimates is a research project, so it works really well when it's maintained. It may or may not extend into being an actual product that stays available. Uh, so randomness is a key element of machine learning and of games, all sorts of things. And one of the cool ways of learning about randomness and connecting it to machine learning is through genetic algorithms. And the Genetic Walker is a wonderful free site where kids can experiment with this. So in the Genetic Walker, the genes are randomly mutated. Now, random mutation of genes yields emergent behavior because you never quite know what will be produced. One of the best ways of learning about emergent behavior is the NetLogo program, available as a free download for Windows or Mac, or web-based for any tablet. So in the image on the left, there's a simulation of the spread of a computer virus through a computer network. High school students could just as easily take that model and, with its own programming language, modify that to model the spread of a human virus through a population, through a city, through a nation, through the world. So randomness connects to genetic algorithms. It's what makes them work, and genetic algorithms always produce emergent behavior. Well, we know that data is so massive that looking at masses of numbers just make your eye cross. So it's all visualized. And there are ways that kids can go from Gapminder, which they may have encountered earlier, and that image to the left actually is displaying 7 different variable values at once. That's pretty wild in terms of understanding of visualization. Very quickly, you can understand deep concepts. Excel in the middle is a standard thing that kids should be able to use and graph with any time, even though the graphing is limited. And then using Kaggle, kids can use the R or Python programming language, graphics extensions such as ggplot2 to create very complex graphs that show complex relationships with massive amounts of data. Visually is the only way to understand this level of complexity, never numerically in tables. So as they get into programming, they would use the languages Python or R, even though currently the language that they're taught in most US high schools would be Java and one of the C families. So that's a small disconnect. But there are programming environments such as Kaggle or Google Colab that are something that kids should get to understand because they really make programming easier. And then there are the machine learning libraries such as Tensorflow and Keras that pack a lot of power into very small pieces of code. So in high school and middle school, with the technologies that we have today, these activities are like holding a small brain to teach in the palm of your hand. And again, the ideas are not like drops that go into sand and disappear, but that cause ripples in a quiet pond where you have no idea where they will stop, possibly affecting their whole lives. The ideas are there'll be intelligent automation throughout kids' lives that will massively impact culture and work. One way to get into this early is through language as the input-output mechanism for machines. The idea that You visualize data to understand it. The idea of focusing on numbers by themselves doesn't work anymore. Algorithms rule. That's something with programming, and high school kids, middle school kids too, need to begin to expand their programming skills so that they understand what's going on behind the scenes. These activities give kids mental tools for their future work and their future life.